Throwback Thursday on the 28th of January. You guys will be able to use triangle inequality, section 6.3, okay? So we're going to talk about inequalities in the triangle, okay? So angles and sides. So we know triangles are made up of 3 sides and 3 angles, okay? Yes, Kelly? I don't know yet. Jacob hasn't told me. What? I picked a random one earlier, though, that a student told me, not random. A student gave me No Scrub by TLC, so I started playing that, which then turned into Destiny's Child, Say My Name. Yes, Aiden? Okay, so angles and sides, okay? So we know the measure of angle C, we know the measure of angle A, do we know the measure of angle B yet?
Yes.
No.
Yes.
Not yet, but can we find it?
Yes.
Yeah, okay, how do we find it?
Well, it's 60.
Do it.
Okay.
180 minus 95 minus 30.
Okay, you take 95 and 35, you're taking both of them away from 180. Whether you add the two, add the two and then subtract it, or you subtract them individually, however you do it, doesn't matter, okay? But you end up getting it to be 60 degrees, okay?
No, 50.
For sure it's 50.
You're right. Thank you.
I was just joking.
50 degrees.
I just used the calculadora.
Okay. So, let's list these angles from smallest to largest in the triangle. So what would be the smallest angle here?
45.
Okay, so angle C is our smallest. What's our next smallest angle? Okay, angle B. And what's the next smallest angle?
95.
Angle A, the biggest one, okay? Now,
Now he's getting serious.
okay.
What's going on?
School demonstration.
Okay.
Yes, oh, I'm gonna get killed. This is where I die.
Maybe. I can't guarantee it's not going to happen.
The blinds are closing. Oh no.
Okay.
Doesn't
You
need
can't
to
see the
close all the way.
wall.
No, I don't need to close all the way. I just need that. Okay. Dark in here, right?
Oh no.
So dark.
Okay. So, flashlight.
Keep
Okay.
it
A
bright.
flashlight. You guys can see the flashlight shining on the wall, right? There's a difference there when it shines versus not, right?
Yeah.
There's a difference there. You guys can see that?
Yeah.
There's no difference between the flashlight and not the flashlight.
Yeah.
Okay. Okay. Bill, can you take another piece of paper out of your backpack?
Yeah. Oh.
Does
Uh,
that be blank?
No.
No.
So
Okay.
this isn't a failure.
Okay. Hope not. Okay. So I want you to hold up these 2 pieces of paper.
Bye bye pencil.
Okay. Yeah. And do you mind if I set this here?
Yeah, I don't mind.
Okay, okay. So what I want you to do, okay, is I want you to cut off some of the light with that paper.
Just some.
Yep. 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 And then cut off some of the other side as well. Kind of angle it in. Yep.
Making a triangle.
Yep. And so you can kind of see how there's still some light there, right?
Yeah.
Now, is there as much light anymore?
No.
No, okay. What Bill did by covering up the sides is he made this light, there's less light coming out now, right?
Yeah.
So this angle, right out at this desk here, okay, and everyone else can, why don't you take a lap real quick around the room and look at this angle real quick,
Can't see it.
okay?
Really bad angle.
Okay?
Can't see it there.
Okay? Okay, I believe in you, okay? Take a quick lap, okay? Is this angle smaller than what the light would be if the papers weren't there? Is the angle smaller than if the papers weren't there?
Yeah.
Yeah.
Okay, totally is, okay? And this side became smaller, right?
Yes.
Yeah.
Move them away. Move the papers away. What happened? The angle got bigger, right? And the side got bigger, right?
Yeah.
Okay? Okay? Sit. You guys can go and sit back down.
You gotta take a lap then.
Okay? Gotta take a lap. Yep.
Oh, I'll take a lap around. Only a mile.
So, we noticed there, when the angle was smaller, the light was shining less on the wall, right?
Sure.
Did we notice that?
Yeah.
Okay. When the angle got bigger, the light was bigger on the wall. Okay. Well, the light was not next to where the light appeared on the wall. It's away from it, right?
Yeah.
Same idea for these angles, okay? So because angle C is away from this side here, side AB, it's kind of like the light shining. Kind of like the flashlight shining from angle C, shining on the side AB over there. Okay? Does that make sense? What I'm talking about there with the flashlight shining there, okay? Okay. So, because this is 35 degrees and this is 50 degrees, which of those do you think is going to have the bigger side opposite it?
50.
The 50 degrees, because it's bigger. Okay? Same idea. The more area you have for the flashlight to shine, the wider the light's going to be on the wall. Well, the bigger the angle's going to be, the farther it can open up for the side. So, light going back on. What do we think our smallest side is of this triangle?
AB.
Okay, side AB. Because it's the side opposite angle C, the smallest angle. It's opposite the smallest angle. Okay? What would be the middle side here? Okay? Side AC, because it's opposite the middle angle, angle B. And so what's that leave as their biggest side? BC. Okay? And because it's opposite, angle A, the biggest angle. Now this is actually factual information. It's not just guesswork. This is actually factual. For a triangle, this is true. Now this would be the order of smallest to largest sides. Okay, because of those angles. So we can see from this that the largest side, or I should say the longest side probably, better way to word it, the longest side and the largest angle are opposite each other. The largest side and the longest angle, largest angle, my goodness, I'm having a terrible time with those words, are opposite each other, okay? Aiden.
What does that mean for, what does that mean for, right, triangles? How does that work?
What do you mean? What? Okay.
And the second thing is, there's never the same angle above the side. Like, there's not a C.
We'll talk about that. I like that a lot. Kelly. Okay? Bill.
What about an equilateral?
Yep, so all the angles are the same.
Yep.
So what can we deduce from that maybe?
All the sides are the same.
All the sides are the same, right?
It doesn't really work for the light thing.
Bill, they'd all be the same measure. So they would all produce the same on the wall.
So they'd all
Yeah. Does that make more sense? All right. So then, conversely, though, over here on the right-hand side with the light blue lettering, okay, the shortest side and the smallest angle are going to be opposite each other as well. Now, Aiden made an observation. Some of you guys might have made this observation as well. That as we looked at the list of smallest angles, from angle smallest to largest and size smallest to largest, when it was opposite angle C, what letter was not used for the side?
C.
C, because it's opposite, it's not touching it. Okay.
Yo.
When it was opposite angle B, what letter was not used?
B.
When it was opposite angle A, what letter was not used? A. Okay. So you might notice on some of these, I can go through these like very quickly, and it's not just because I'm a math teacher, but it's because I noticed that pattern, and so I say, oh, what are the other two letters? What are the other two letters? What are the other two letters? And that's how I do them very quickly. But the thought process behind it is, oh, it's going to be opposite that angle. Okay? Okay? Math hacks. Okay? So, I want the sides and angles for number 1 from least to greatest. Okay? Sides and angles for number 1, least to greatest. Okay? When you have more have questions, raise your hand. The first one, we have to order them smallest to largest, but this time we don't know the angles, we know the sides, okay? So we know the smallest side is side AC or CA. We know the next smallest side is side AB or BA. And we know the next side is side CB or BC. So the angles are going to be opposite those. So opposite side AC is going to be angle B. Angle A. Smallest side, smallest angle, angle B. My goodness, I got myself mixed up. Okay, redo that. Okay, next smallest angle, angle C, followed by angle A. It's all about where they're opposite. Okay, and then like I said, the math hack here, what letter's not included? AC, oh, it's B. AB, oh, it's C. CB, oh, it's A.
I'm not smart enough to do that. I had to look.
I get it.
Okay, okay. Did that make any sense to anyone or no?
Yup.
Okay, okay. That's the math hack I do. It's like when I go around and check yours real quick, I check like the angles, and then I just real quick check the sides. So I'm like, oh, okay, not those, not those, not those. Cool. Okay. Yeah, Aiden. Like largest to smallest? What do you mean? Flip it around.
I'll give you some angle
You
C.
put the sides and the angles and the angles on the sides.
Well, in what way, Aiden?
Like this.
Okay, so you did largest to smallest instead of smallest to largest. Okay. Okay, Bill.
What if I did not label on the homework?
Okay, then you'll probably lose some points. Labels are important. Okay. Any questions on these two guys?
Why?
Okay. Are we feeling? Give me a thumbs up if you're feeling good. Thumbs down if you're not. Okay. Okay. Be real with me here. Okay. Do you guys feel like we need to do examples 3, 4, and 5?
Yeah. No.
Probably not.
Just that.
I may get them though.
I want to do a question related to class.
Oh,
Okay. We're gonna skip those. Okay.
Oh, that's really cool.
What?
I didn't even need you for. Those are not
so good.
Mr. Claus, I don't feel so good.
Rulers don't.
Oh no, not rulers.
No.
So, we're saying here, if we take 3 line segments, if we just take 3 random segments, we may, or we may not, be able to form a triangle with them. Sometimes you can take 3 line segments and make it form a triangle. Sometimes you can't. Sometimes it works, sometimes it doesn't. We can see here some examples where it does and doesn't work. Okay. Now, we should know that each of these rulers should be how long?
12 inches.
12 inches a foot, right? Okay. That'd be reasonable to say, right? They're all 12 inches since they're all normal
Not
American
Liam's foot.
100 centimeters.
rulers, okay.
Not
Or
Liam's
what?
100 centimeters.
I don't think it's exactly 100.
It's like
It's like 30 and a half.
Is that bigger than Liam's?
Oh, they don't use foots. Never mind.
Yeah, they don't use
You
foots.
guys,
Foot is-
you know what I
They don't
meant.
use whatever the plural of foot
They
is.
use
It's a mystery to all of us, okay?
Foot is
So,
Foot eye.
let's just say I put 3 of these together, and that's the side of a triangle that is 3 feet long. Okay, is that fair to say?
Yes.
Okay. Okay. And let's say I put 2 of these together, and that's the side of a triangle that's 2 feet long.
No way.
Okay. And I put 2 of these together, and make a triangle that's
Doesn't work.
2 feet long.
It
Okay.
doesn't work.
Can I make a triangle?
Yeah.
No.
Yeah, the
Yeah,
triangle's
it's a
two feet
triangle.
long.
See that gap in between?
Okay.
Yeah.
So if I fix that gap, would it make a triangle?
Yep.
Yeah.
Okay. So it makes a triangle. Okay.
No.
There we go.
So it makes a triangle, right? Okay. So the side lengths of 3, 2, and 2 can make a triangle, right?
Yes.
Okay. What about
We had to blow our mind.
Nah.
if we were to have side lengths of I don't know. Let's say I make that side length 5 now. Okay. Let's say I make that side length 5 now. Okay. Can anyone come up here and try to make a triangle out of that?
I'll do it.
Get Gage, embarrass him.
Wait.
Embarrass him.
I'll do it.
Wait, who?
Okay. I think the first 2 hands I saw were Gage and Jacob, so rock, paper, scissors for it.
Trigger.
Just give it
Make
to
him
Gage.
win. That was the last
Okay,
game.
okay. On shoot, guys. Come on, civilize.
That's the
Look like civilized people.
Rock, paper, scissors, shoot.
Okay, so Jacob hand sanitize, and then try and make a triangle out of that.
Out of 5?
Out of a side of 5, and then the other 2 are still 2s.
In 2nd grade, everybody used to pick scissors first.
It's not possible.
You just tell them you're gonna go rock, and then use the reaction.
No, everyone picks
Everyone
rock
picks
because
rock.
you think the rock is the
It's
strongest.
a mind game.
Like, okay.
Everybody used to pick scissors because I looked it up.
There's
one
actually
time.
a lot of psychology to it. So a lot of guys will typically pick rock because it's more masculine and stuff like that. So like if you're playing against a guy, they're more than likely going to pick rock first. It's the highest
Jacob,
percentage
explain.
wise. But like it's actually like it won't always work. But like I'm like low key like actually really good at rock paper scissors. It drives my wife nuts because we'll do like rock paper scissors to decide on things, and I almost always win, and she hates it. Or if we say fine, whoever loses does this, and like I'll lose on purpose because like whoever loses has to stick dog out, and I lost on purpose one time. Like just a few nights ago, and she got so upset. We were like, "You're welcome," and she's like, "No, don't lose on purpose. You didn't do that." And she's getting all mad. I'm like, "No, like I did." It's just like driving her crazy.
Losing is just as hard as winning.
Yeah,
What?
yeah. It takes skill to purposely lose a rock paper scissors. Just saying.
I don't know how you purposely lose a rock, paper, scissors.
You know what they're gonna pick, and you pick the losing one.
Yeah, but how do you know what they're gonna pick?
They're not gonna
You're
connect.
really
It's
good at rock,
4
paper,
of
scissors.
them.
Ready? Let's go.
Mind games.
I'm gonna pick a rock.
Okay.
Small gap
First you
between
gotta blink
each
and then
ruler.
blink twice.
Just have
What?
a small gap
Yeah.
between each ruler.
Okay, Jacob, how's it coming along over here?
Not working.
It's not working.
Grab another ruler.
Does anyone else think they can make this work?
No,
Okay, with these sides, does anyone think they can make
Oh,
it
with
work?
those sides. No.
Yeah.
With
wait,
these
wait.
side lengths, does anyone think they can make it work? Aiden, are you serious? Are you joking?
I mean, I was just gonna grab
What?
2 of those.
Yes.
I don't know. Guess which one?
You final question.
Okay. Hey, Jacob, why don't you grab another ruler?
That's what I was gonna do.
Yeah, why don't you grab one more ruler?
Uno mas.
And add it to any side length you want.
Not the log one. It's
Any
55.
one side length you want.
Uno mas.
Goes next to its friend here.
Wait, I think.
No, you slow now.
What?
You were too slow. You can't do it now.
No, you're slow now.
Maybe we have to call the ambulance saying you're having a stroke. I'm not gonna lie, dude.
Oh,
Ah.
triangle.
Yeah.
That looks like a diamond. Triangle.
This is already closer.
This is a fun time over here. We're just gonna.
Wait, I want to do
Boom,
my hand.
touch.
Not long enough.
Oh, no.
Too wide.
You obviously can't make it because
Yes, I
there's
can.
a
Look at that.
You have to have 5, 4, and 2.
Did you like
So we're clear. It's gonna be touching there.
Wait,
Oh.
wait.
I like you because you didn't do anything.
That
Yeah, are the rulers lined up evenly though?
I like it
To
just
touch?
like a bomb.
Perfectly.
We go over.
that's very. That's not a triangle.
That's a curvy side. Anyone notice that side curving?
That's very curvy.
No. No.
Hold on, I think I can do it.
You think you can do it with this one?
Yeah.
I just did it.
I don't think that's a triangle, buddy.
That
think
is
it's-
clearly a triangle.
I think this side's pretty curvy.
What the heck? That's not a triangle.
I think we just solved the
That is a triangle.
We just solved one
massive
other, guys.
mystery.
Yeah, well, they're all different rulers too. So.
We just solved one other.
Yeah, I think these are pretty curvy. I think the only way you can make it work
Is if you line them up.
is if you do it
Which
like
is what I was
that.
going to do.
But it's not a
But is that a
triangle.
triangle then?
Yes.
Wait, I had a theory like that.
Does that actually have 3 angles and 3 sides?
Yes.
Yes.
No, it actually doesn't because an angle measure would be 0.
Wait, there's two.
It wouldn't exist.
It's 4 sides. 1, 2, 3, 4.
That's a square.
That's-
It's a
So,
rectangle.
so thanks for proving my point. It's not a triangle either way, okay? So what if we take some different ones, okay? So thanks for trying that, Jacob. I appreciate that, okay? Let's say we take some different ones, okay? So let's say we have a side length of, or what do we think might make it work? Actually, let me ask you guys. What do we think might make it
2
work?
more.
Okay. Gage, why don't you come up and show me what you think might make it work? Okay?
Can I have another ruler? or
Sure.
no?
Yep.
Yeah.
Can I say that first?
Don't
And why
fail.
don't you show me what you think might make it work? Yeah.
I know.
Don't fail, Gage. It'd be kind of
Wait,
embarrassing.
you have to
It's
use
almost
all
like the
sides.
answers are right in front of us.
I know.
Yeah.
Exactly.
Yeah.
Like,
So, you
look
see-
around.
I could argue that if you're adding, you could also take away.
Wait, can I draw a triangle? I have an idea.
Okay. I mean, you could draw it on a piece of paper.
Is it
Wait,
the?
we have a really long side.
Wait, what if?
Ooh, triangle.
What would a 1 degree triangle look like?
It's look like a real
No,
triangle.
Triangle.
But you make it like.
Because I can.
TriangleMaker.com.
Mr. She has a good point.
What's her point?
After he's done, I'd like to.
She can solve your 5, 3, 2 mystery.
There you go.
She just did.
Oh, that.
According to the triangle equality equality
recording here.
equality theorem, Gage is okay.
It is a triangle. I'm gonna see if you look into it.
Yeah, like that. And I gotta move them all down. Like
This is a triangle.
There we go.
That's a triangle.
Okay, that is a triangle. Gage, what did you have to do to make this triangle work, though?
Well, I had to add an extra ruler.
He had an extra ruler. He had to make another side. Instead of having 5, 2, and 2, side lengths of 5, 2, and 2, like Jacob started out with, or 5, 2, and 3, like we changed it to, he had to change it to 5, 2, and 4, okay? Well, what about, does anyone, Kelly, yeah, what's up?
Is it because the 2 sides that are shorter can't equal the longer side?
That's part of it.
It has to be greater.
Yeah, so those 2 sides, the 2 and the 2, the smaller 2 sides, they didn't equal, they didn't equal 5 and it didn't work though either. But the 3 and the 2 equaled 5 and it didn't work. So what do we think? Gage, you said something there?
Yeah, it has, the 2 sides combined, that have to be bigger than the biggest side. Sort of.
Okay, so the 2 small sides
Yeah.
are going to have to be bigger than the biggest side. So what if I gave you the side lengths of, let's just say randomly, I give you the side lengths of, I don't know, 20, 60, and 75.
Yes.
Yeah, you good.
Maybe.
Say maybe
Okay.
that's 5 more.
Would that work? Could we make a triangle with those?
Yes.
Why? Why?
Because the 2 smaller ones add up bigger than the biggest ones.
Yeah, but what if I say now instead of 20, 60, and 75, I say 20, 60, and 90?
No.
Why not?
Because the 2 smaller ones don't add up to the bigger ones.
Because the smaller ones aren't greater when they're added together than the biggest one. Okay, so we can take it with these sides here. We saw when we had 2, 2, and 5 didn't work. 2, 3, and 5 didn't work. 2, 4, and 5 it works. What if we were to do? Anyone want to try 3, 3, and 5. Anyone want to try 3, 3, and 5 over here? Okay.
I do.
Billy, want to go?
Yeah.
Okay. Hand sanitize.
3, 3, and 5.
Let's go, baby.
No, I made a triangle.
Yeah.
It was just like,
Such a
oh, this
fucking
was
thing.
lines on them.
It was.
It was a triangle.
It was curved. In Euclidean geometry, it's not a triangle.
It was like me.
Yeah.
Man, what is this? Oh, this isn't
Curved.
Euclidean geometry.
Yeah, it
This
is
is
Euclidean geometry, it's not
Jacob's
triangle.
geometry.
Speaking of curves,
Was that?
Dave. You're an idiot.
Yeah.
I just saw that.
I'll explain it.
Oh.
That was really
Ready? This is gonna blow your mind.
I'm
Okay.
glad. I'm glad I saw that.
yeah, you
I
are.
didn't see it.
Tom.
I'll show you.
Yeah, Kaya.
It is a triangle.
What?
You're gonna let me.
I'll let you show your
It's a
thing in a moment.
triangle
Yeah.
with a line.
I just do it. Let me see.
Right there.
You're just casually covering up because you don't want to do the work to get it there.
Just show it.
Wait, is it possible?
It is.
Easy, let's do this.
Yeah, this is possible.
Genius, right? It's a
Oh, that actually was kind of easy.
That's facts.
Done.
Okay, close.
It's a
Close.
house.
Yeah, we'll count it.
Yeah, it's a house.
Okay, so you can make one with 3, 3, and 5 as well. So it didn't have to be like 2, 4, and 5. 3, 3, and 5 works because 3 plus 3 is
5.
6.
6.
Oh my will.
So 3 plus 3 is 6. Okay. Now, Kai, do you want to show yours? Okay. Go ahead and sanitize and show us yours. Okay. Her idea of
I can
doing
do.
it was a what? It was a 2, 3, and a 5. Your idea of trying to make it work. So,
It could be
I
a
mean,
2. It could
it
be a
could be
5,
1 and 1.
okay.
5, 1, and 1.
Okay. You want to do your 5, 1, and 1?
Or 5, 1, and 2.
She's like challenging.
5, 1, and 2 is good.
Okay.
It's a triangle.
So
Hey, that's what I did.
Shorten that out with the triangle, okay? It works. Okay, technically you didn't make a triangle, but not with the actual side length of 5, right?
But
One of
it
the
is
side
a
lengths
side
is like
length of
1 1/4, 1 1/3.
Oh,
It is
So-
a side though.
It's this side.
But it's not the actual side of the triangle.
That's
So
what
the
I
side
did.
of
It is the side of the triangle.
the segment,
wrong.
the entire segment
You're
is
wrong,
5.
Aiden,
She made 2 triangles.
This.
Oh my. She made 3 triangles.
Oh, she has you guys. She got you.
So the side length of each triangle is 1, 1, and then 1 1/2, 1, 1, 1 1/2, 1, 1, 1 1/2. Okay. All right. So I still made a triangle. Okay. So guys, what we noticed is actually entirely accurate. Okay. The sum of any 2 side lengths of a triangle is greater than the third side length. For it to work, you have to be able to add up any 2, and it has to be bigger than the third. Now, for our purposes, does it matter if, do we really have to check if we add the biggest 2 and it'll be greater than the smallest one? If we added the biggest 2, is it always going to be greater than the smallest one? Yeah, whatever the numbers are. Okay, let's say they're 4, 2, and 5. If I add up 4 and 5, it's going to be 9. Obviously bigger than 2. If I add up 5 and 2, obviously bigger than 6. Than 4, because I was thinking 4 and 2. Obviously bigger than 4, because the biggest number's involved. So you really just have to check the smallest 2 sides. Okay? So you really just have to check the smallest 2 sides. So I would just put a note there, okay? Check the smallest 2 sides. Because if those work, then it can make a triangle.
That's a nice double L.
Yeah, thanks. I was real proud of it. Okay? Check the smallest 2 sides, okay? Now, as you notice on these little triangles or these 3 segments trying to form a triangle, these little red swings, it's kind of like if it were to swing through and it's fixed on that vertex. So they have to connect there, okay? So it's just kind of swinging through. So let's say it's stuck there and it's kind of swinging through like, oh, this is the spot it can swing at. So like the 2, 2, 5, the closest thing it is there. The 3, 2, 5, the closest thing it is where they actually just touch and it forms another straight line. Okay? Yeah, Bill.
Can you take a screenshot, make a star, and it correct it?
Yes.
Wait, actually, try.
It'll pause my lesson that I'm recording, but yeah.
You can just make 2
Why
left.
does it think it will?
Question.
Yeah.
Does that say check the smallest? Or
But you can't see that one, I guess. So it's on my screen that I do the star. It's in green, so it's kind of hard to tell. But you can't tell it on yours. Because I guess on this program, it just doesn't show the screenshot.
Whoever's watching this at home is probably like,
Yeah, it's a good thing everyone's here today. Let me just say that. Him. Anyway.
What about invisible block? I'm not trying to see
No,
that.
he's right
Oh
there.
yes, okay. All right. Any other questions on this?
Does that say smallest or smallest?
Smallest.
Oh, that does say smallest.
I want to know 3. Because it's basically the
It is wrong.
Okay, so on these problems, is it possible to form a triangle with these side lengths 8, 5, 15, and 17?
Yes.
Two. I like two.
Yes, okay, because 8 plus 15, the two smallest, is 23, and 23 is bigger than 17. Yes. Now, on a test, hint, hint, hint. Okay? Okay? I'm going to say show your work for the full points. AKA, if you just put yes or no, I don't give you the full points.
But I put young.
Okay? So at least put 23 is greater than 17. That's enough to show me, hey, I know what you did. I know you did this the right way, rather than just took a 50-50 shot of yes or no. Okay? I'm not going to put a question on a test and just say, oh, you can get all the points by getting a 50-50 shot of yes or no. That's not a very good test.
How am I supposed to get answers?
Okay? That's not a very good assessment of what you actually know.
Maybe you could put yes, no, or maybe.
Or maybe so.
Yes, no, maybe so. Okay, Dominic.
Or math.
We could just put 23 is greater than 17 and no yes or no.
You would have to put yes or no as well, because this is your work, this is your answer.
So question.
Answer, work, answer, work, answer, work, work, answer. Okay?
So if you got the work right and the answer wrong, would you get half?
You would get partial credit. Yeah, Kelly.
By that one, what you're saying is the ACT kind of just doesn't really work.
So the thing with the ACT is because there's so many questions and there's more choices than just two. So each question is like technically like a 20% chance. I think you have like A through E. Maybe it's A through D. So it's either a 25 or a 20% chance. So that changes it as well as having so many. But yeah, it's like less accurate than if it was like open response, like an AP exam, which are a lot of open response for parts of the test. If that makes sense. Yeah. Fair question though. The AP exam is an exam after you take an AP course, advanced placement course, and then you can try and get college credit. It's one of the ways you can try and get college credit for a high school class. Yes, good luck. Okay. Let's look at example 2. 6, 8, and 14. Can we make a triangle with these side lengths?
No.
Why not?
Because they're not greater.
6 plus 8 is equal to 14, and last I checked, 14 is equal to 14, not greater than it, so no. So you can put 14 is equal to 14. You can, for your explanation, you can put 14 is not greater than 14. Okay? Yeah.
On a test, would you ever do like 6.1, 8, and 14?
I would be that person.
That'd be pretty funny.
Yep, I would be that person. I'd make it that close.
You really good on
Okay.
that side, yes.
1, 2, and 25?
No.
No.
Yes, obvious.
Yes, obvious, okay? Because 1 plus 2 is 3. Unless I check 3, it's kind of less than 25.
I don't think so.
Not only is it less funny, yeah, just a little bit, okay? But it's also just less quantity-wise. Okay?
Section left.
So can an isosceles triangle, remember isosceles has two sides the same, have the side lengths 5, 5, and 10?
No, because that is not a triangle, it's a straight line.
No, because it can't even make a triangle, okay? Because 5 plus 5 is equal to 10. And 10 is equal to 10. Okay? Or we could say that it doesn't even make a triangle, it makes a straight line, all these things. Okay, yeah.
You said on a test, like just saying no would be incorrect. What about a homework?
If I say explain, you need to explain.
Okay,
On the paper and in real life.
If I say explain in real life or on the paper,
Okay.
it means to explain it.
Got it.
Only paper.
Okay, if the instructions for that section say to do it, do it.
Okay.
Okay,
That sounds-
all right. Any other question on this section before we move on to the last part of the notes? Like, real quick. Okay, so if you know two sides of the triangle, okay? If I know two sides of the triangle, let's say back here, okay? I know one triangle has a side length of 5, and the other has a side length of 3. And I don't know the other side length yet, okay? We just know two side lengths. I know a side of 5, I know a side of 3. Well, the third side, does it have to be a very specific length? Does it have to be like exactly this? No, okay. We saw how we could do 5, 3, 3. We saw how we could do 5, 2, 4. We could probably do a 5, 3, 4, right? We probably make this side 4 even. We might even be able to make this side 5. Maybe make this side 6, 7, 8, 9. Who knows, okay?
Not
Well,
9,
there's probably... Well, not 9. Why not 9?
Not 8.
Or not 8. 'Cause
Why not 8?
5
Because
plus 3
straight line.
is 8, and 9 is greater than 8.
Because then all of a sudden 3
You're
and
just
5
looking at the
are the two smallest sides, right? 3 and 5 are the two smallest sides. So there's a range there. Okay? There's a range where it can fit between. So for for sides 5 and 3, we said it can't be 8, so it has to be less than 8, right? Could it be like 7.9?
Yes.
Okay, so it has to be like less than 8. Okay, and what's the smallest it can be for 5 and 3?
3.
Okay, the smallest it can be is 3.
Yes.
Yeah.
What about 2.1?
No.
Actually.
Wait, yeah.
No, it couldn't.
No.
So it has to be greater.
Yes, it could. It could be 2.
It has to be greater than 2, right? Because then 2 and 3 would be our smallest ones. Okay, 2 and 3 would then be our smallest ones. So it has to be greater than 2, but less than 8. It can fit anywhere in that range, right?
2.01.
Okay, so mathematically, how can we have a formula here, so to speak, okay? A pattern we can use that we can always find the range quicker. Instead of just kind of saying, playing mental games in our head. If you want to, you can. But instead of playing mental games in our head like we just did, take the big side of the 2, subtract the little side. That's going to be your lower bound. Okay? So here, 5 minus 3, 2. That's the lower boundary, or lower bound as we can call it sometimes in math. Okay? The lower boundary. It has to be greater than 2. Other one, take your big side plus your little side. 5 plus 3, 8. That's your upper bound, or upper boundary. Okay? So it has to be less than that. So it has to be between the difference and the sum.
So 9.
But it can't be that one.
But it can't be either of those. Just like here, it couldn't be 2, and it couldn't be 8. It couldn't be the difference, and it couldn't be the sum. It has to be bigger than the difference, smaller than the sum. Okay? So your side length has to fit somewhere between those two. It can be anywhere between those two, but somewhere between them. Aiden,
So it's between.
are you trying to do this problem right now?
Yes.
Okay. So on this problem, we'd set it up, and we'd say, okay, well, 12 minus 3, that has to be less than x, or our third side length. And our third side length, x, has to be less than 12 plus 3.
Is that how you set it up?
That is how you set it up. Yep. Yep, great question. That is how you set it up, okay? So you do, so big side, 12, minus little side, 3, is less than x, is less than big side, 12, plus little side, 3. So you say, okay, well, 12 minus 3, that's 9. That's less than x, which is less than 12 plus 3, 15. So x is somewhere between 9 and 15. So that third side can be anywhere between those two numbers. And then this is actually just our answer.
Oh, that's easy.
Okay? That is our answer. It has to be between those two side lengths. Because we're just finding the range. We have no other information where we could possibly know what the other side length has to be. Specifically, we just know it has to be in this range. Yeah, Bill.
So if we just put greater than x, greater than, all we have to do is simple math.
Yeah.
That's easy. I mean, that's difficult. You should have that for homework.
Yeah.
Oh my gosh.
I think you mean less than x, less than, but yeah.
Might get some raises.
I will say it's easy, but you can set it wrong. I mean,
All right. So on 2, when we have 4 and 9, who can tell me what math we'd have to do here? Set this one up.
Nah. Simple.
9 minus
Huh?
4 less than.
Yeah, 9 minus 4 is less than x, which is less than 9 plus 4. The difference is less than x, which is less than the sum. So 9 minus 4, that's 5. It's less than x, which is less than 13. Any question on that one? Okay, Seth, what does x have to fit between on number 3?
14 minus 10.
Okay.
14
Okay, 14 minus 10 and 14 plus 10. Okay, and that would end up being 4 and 24. Haha.
That'd be funnier than 24.
What?
25.
All right. Any question on that, guys?
Why?
you
What else is
know,